Hi Claudine, this video is for you to help you out with worksheet 10.2. So what you missed the other day basically involved two things. We started with, suppose I wanted to find the area of an equilateral triangle with a side length of 1. What would its area be? So you're like, how do you do that? We know the base, but how do you find the height? Now remember, cutting an equilateral triangle in half basically forms a 30, 60, 90 triangle, right? So if this is 1, like this is 1, right? And if that's 1, this would be 1/2, right? Cool, I just wanted to make sure we were still live. Sorry about that. So anyways, so that's 1, that's 1/2. If you use the Pythagorean theorem, that squared minus that squared would get you to the square root of 3/2. And basically find the area of that. The area would just be square root of 3/2, that's the height, times the base, and then just divide that by 2. But wait, the base isn't 1/2. The base is actually 1. So that was a fail. So the height times the base divided by 2. By the way, it's late, so I apologize. And you get the square root of 3/4. Right? Okay, so we have this shape, and that's how you find the area of an equilateral triangle. Now suppose I said, well, what if I wanted to find the area of equilateral rectangle, which is actually called not a rectangle, that's a hexagon. And you notice, like, but Mr. Reno, we haven't turned anything about these special hexagons. We haven't, but reality is a hexagon, particularly a regular hexagon, has the same sides and angles, is just 6 equilateral triangles. So just like in problem number 2, and just like in problem number 5. So you can use that idea. So for example, if I know this has a side length of, I don't know, say 3, or let's say 5, right? Let's make an even number. Let's make it 6. If this is 6, right? And then we can just find the area of this one. I don't like that. Let's make it 10. Sorry about that. This length is 10, and that means half of this is 5. And then basically, if this is the 30, 60, 90 triangle, to go from here to here, you just go this times the square root of 3. So it's 5 times the square root of 3. So you find the base, which is 10, times the height, which is 5 times the square root of 3, divided by the 2, and you find out that the area of that triangle is simply 25 times the square root of 3, right? If you notice, there's 1, 2, 3, 4, 5, 6. So to find the area, there's 6 triangles. So to find the area of that whole hexagon, you just multiply that by 6, and that would just be 150 times the square root of 3. So you use this logic to answer number 2 and also number 5. So that covers 2 and 5. The first problem we did about triangles, you should be able to use to answer question number 4. For question 3, well, question 3 is about circles, which we sort of covered about. So again, if the animal's here, the radius of approach would be like, no one can be within like this close. So for example, if it's a sea turtle, this would be 20 square feet, or if it's a monk seal, it would be 100 square feet, which I actually got to see in Hawaii a number of years back. So that's what that meant. So it shouldn't be too bad there. And then same thing here for number 6. 6 is also a, what do you call it? A circle. So let's focus on what you might know. So for number, 5 it also, 7 also talked about circles. So I hope you can figure that out. For number 5, it uses the word apothem. So I guess we didn't really go over that. So the apothem is actually, it's almost like the height of the triangle of a particular polygon. So for example, here, the apothem would have been 5 times the square root of 3. So if we changed it up a bit and said, well, what happens if that apothem was like, I don't know, maybe make it 7. If that's 7, how do we go from here to the base? Well, basically, that was a funny pun. instead of multiplying by the square root of 3, like we did over here, we did 5 times the square root of 3 to get 5 times the square root of 3, we just divide. So this would be 7 divided by the square root of 3. So this section from here to here of that little triangle would be 7 over the square root of 3. And that means the whole thing, well, actually, if you want to do it in simplest radical form, multiply by the square root of 3, and then the whole thing gets 7 times the square root of 3 over 3. Sorry for choosing a horrible number. And if that's 7 times the square root of 3 over 3, you just got to double it. You get 14 times the square root of 3 over 3, and that becomes the whole side. And from there, you can find the area of that triangle, and that triangle, and that triangle, and that triangle, and triangle. What's cool about this is any shape, such as like a pentagon, could also, you can use that apothem strategy as well, because any regular polygon can be divided into a bunch of equivalent triangles, even though some are less equivalent than others. I apologize for that. Assume they're the same. Now, the one thing about this is, though, these are not 30, 60, 90 triangles. That's only true with the hexagon, which cuts it into equilateral triangles. So for here, if I gave you the apothem, so for example, let's just make up some numbers, not really, because I have the numbers here. So that's about 3/4. So example, if this is, I don't know, 6, and this is about 8, what would be the area of the whole pentagon? Well, you just find the base and the height. That would be 48. Remember, area of a triangle is base times height over 2. So that means this area is just 24. And if you notice, there's 1, 2, 3, 4, 5 triangles. So you just multiply that by 5. And the area of this whole pentagon is 120 whatevers. Cool. So with that information, you should now be able to answer number 5, which talks about the apothem. Don't worry about number 1 because it's sort of impossible, because we sort of skipped something that was important there. And for here, we'll give you a little hint. If the side length is 16, it turns out that the apothem will be just about, 11. So if you know the side length and you know the apothem is 11, you should be able to get the right answer. So anyways, tomorrow I should be here at 9:30 a.m. in case you want to go over some of this. But hopefully this helps, and hope you have a good night.